Hello friends, welcome to aimstoday YouTube channel. In this video, we are going to discuss about IIT-JEE NEET Foundation Chemistry Atomic Structure chapter. From this, let us say about Planck's quantum theory. Before learning about Planck's quantum theory, let us know few things here. As progress in science field was happening, Maxwell's suggestion about the wave nature of electromagnetic radiation was helpful in explaining the phenomena such as interference, diffraction, etc. However, he failed to explain various other observations such as the nature of emission of radiation from hot bodies, photoelectric effect, that is, ejection of electrons from a metal compound when electromagnetic radiation strikes it, and the dependence of heat capacity of solids upon temperature and line spectra of atoms, etc. These all phenomena were not explained by him. So let us see here what is blackbody radiation. When certain energy falls on the surface of a body, a part of energy is absorbed, a part of it is reflected, and the remaining is transmitted. All the incident radiant energy is not absorbed completely by the body because ordinary bodies are not perfect absorbers of radiant energy. However, an ideal body is expected to absorb completely the radiant energy falling on it. Such a body is known as a black body. This phenomenon could not be explained with the help of Maxwell's suggestion. Hence, Planck proposed the Planck's quantum theory to explain this phenomenon. In order to explain blackbody radiation and photoelectric effect, Max Planck in 1901 presented a new theory which is known as Planck's quantum theory of radiation. According to this theory, the smallest packets of energy are called photons or quantum. Substances absorb or emit light discontinuously in the form of small packets or bundles. The radiation is propagated in the form of waves. The energy of a quantum is directly proportional to the frequency of the radiation. So mathematically it can be represented as E is directly proportional to nu. So the energy of a quantum is given as E is equal to h nu, that is also equal to hc by lambda, where nu is equal to c by lambda. So this can be substituted 1 by lambda as nu bar, that is also equal to hc nu bar. So these are different terminology for calculating the energy of quantum, where h is called a constant, Planck's constant. Its numerical value is 6.625 into 10 to the power of minus 27 erg second, or 6.625 into 10 to the power of minus 34 joule second. E is the energy of the radiation in terms of x or joules. C is the velocity of light, which is taken as 3 into 10 to the power of 10 centimeters per second, or 3 into 10 to the power of 8 meters per second. And nu is the frequency of radiation, lambda is wavelength, and nu bar is a wave number. A body can absorb or emit energy in whole numbers of quantum. So, as you said, this is the energy of a quantum. So, any body can emit or absorb energy in the form of in whole numbers of this quantum. So, that can be given as E is equal to nh nu, where is E is energy and n is the number of quanta, and the energy of each quanta is taken as h nu. Let us say a simple solid example based upon this Planck's quantum theory. The question is given like this: a green light has a wavelength of 525 nanometers. Determine the energy for this green light in joules. So they have given wavelength and also to calculate the energy for this green light. So let us say solution. To find the energy, as we know that E is equal to h nu, or E is equal to hc by lambda. So let us take this formula, E is equal to hc by lambda, because here they have given the wavelength, and we know h as a h and c as constants. So we know these values. We substitute these all to calculate energy. So if we substitute the values of these all, h value, that is Planck's constant value, 6.625 into 10 to the power of minus 20 minus 34 joule second, and the c as velocity of light, its value is 3 into 10 to the power of 8 meters per second, and lambda is given as 525 nanometers. So if we convert this into SI units into meters, 525 into 10 to the power of minus 9 meters. So by calculating, we get energy as 0.0378 10 to the power of minus 17 joules, or 3.78 into 10 to the power of minus 19 joules. Thus, a green light has a wavelength of 525 nanometers, has an energy of 3.78 10 to the power of minus 19 joules. So in this way, we can calculate the energy if the wavelength is given. Not only the wavelength, if they give frequency, you can calculate energy by using E is equal to h nu. If they give wave number, we can use the formula as we have seen earlier, E is equal to hc nu bar. So by giving one quantity, we can find out the other quantity by using these equations. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.